Hello everyone and welcome to the Math Bender. I am Adnan Zaidi and in this session we will talk about trigonometry mathematics cosine rule. Before this we already have discussed sine rule, and in this section we'll precisely talk about what are the conditions of applying cosine rule. Let's start. Okay, so let's say if we have a triangle and ABC, calling the opposite side of angle A small a, this small b, and this side small c, and it's not a right angle triangle. Cosine rule states that a squared is equals to b squared plus c squared minus 2 times b times c cos of opposite angle to the side that you're trying to find. Now, if you want to not remember the formula, all you need to understand that, let's say if you were to find this side and you have other two sides given, the one highlighted with blue and this opposite angle to the side that you're to find, and this is the perfect example for cosine rule. Now, what are the conditions for applying a cosine rule? So the conditions will be, you have to find a side where you have rest of the two sides given, and an included angle. When I say included angle, I mean the angle that is in between the two sides that are given. There's one more condition. All the three sides given and you are to find any angle. We'll look more in detail when we solve some of the questions related to it. So these are the only two conditions where you'll be applying cosine rule. Rest of all the conditions are for sine rule. So rather than remembering where to apply sine rule, you would rather remember to apply cosine rule, and whichever conditions, if these two conditions are not met, it's understood that it is going to be a sine rule question. So let's see some of the questions here. So in the figure, the point B lies on AC line. So this means that on this line AC, point B is lying somewhere and the dimensions are given. You have to find out the length of CD. Now, looking at the length of CD is this. And if I look at the triangle BCD, so from triangle BCD, I'm taking help from triangle BCD, that's why I wrote it like that. So this angle here is going to be 180 minus 125 because it's a straight line and supplementary angle. So 180 minus 125, which gives you 55. Now, one way to look at it is that, as you could see, that both the angles, so this angle is equals to this angle, hence this side is equals to 9 meters as well. It's an isosceles triangle. So since you write isosceles triangle, CD is equals to 9 because both the angles are same. Now you have to find out the length of AD. This is the length that you have to find. Now, if now I look at triangle ABD, and I can see that this is the side that I need to find out. I have rest of the other two sides given, AB and BD, and the included angle as well given. So what I could do is I write AD square is equals to square and addition of the two other sides. So 8 squared plus 9 squared, I added this side and this side, minus 2 times 8 times 9 cos of 125. So rather than splitting and solving it, we straight away apply the whole thing in calculator. So 8 squared plus 9 squared minus 2 times 9 times 8 cos of 125. Note that I'm writing down the whole thing and it gives you 227.6. So AD squared is going to be 227.6 and AD is root of that. So straight away root answer, which gives you 15.1. Okay, so let's look at this one. So you are to find out, these are the two parts QRS and PQS. You are to find out the length of QS. So first step, highlight what you are to find and then look which triangle will help you out in this matter. So if you look at it, I need to find this length, and if I take example from PQS, I have an opposite angle given which I can take help from, and I have another side PS given, but I don't have an opposite angle given. But as I could see from triangle PQS, I can find the third angle since I have rest of the other two angles given. So angle Q is going to be 180 minus 38 minus 55. Sum of all the angles in a triangle is 180 degrees. So angle Q is going to be 87 degrees. Now you have angle P given. You have to find the side that is opposite to angle P. You have now angle Q and the side opposite, the case that could cater to sine rule. So sine of angle 55 over QS is equals to sine of angle 87 over 460, and you cross multiply them and eventually you will get 460 sine 55 over sine of 87 is equals to QS. So straight away applying that, so QS is going to be 377.3. I'll write that down, 377.3. Now you are to find out RS. This is RS. Now for RS, as you could see triangle QRS, so from triangle QRS, now as you could see that this is the side that you're to find out and rest of the two sides are given now and included angle. So this is cosine rule. So I write RS squared is equals to 377.3 squared plus 325 squared minus 2 times 377.3 times 325 cos of the included angle 32. Three 325 squared minus 2 times 377.3 times 325 cos 32. So this gives you a big value and all you have to do is root it. So if you root this, it will give you 200. So RS is equals to 200 meters. What is the shortest distance between PS and Q? Now, the shortest distance, whenever they talk about the shortest distance, it is about perpendicular height, because that is the only shortest straight height that a question would target to. So this is the shortest distance. I'll use some other color. So this is the shortest distance, and you are to find this length. Now let's call this point where it is touching PS X. As you could see, there are two triangles, PQX, in which one angle is given, rest nothing is given. But from triangle SXQ, I'll highlight that, this one. Now from this triangle, you have a side QS given, and you have 38-degree angle given as well. So, and you are to find the opposite. So straight away it's a right angle triangle because this is the perpendicular height, and so sine of angle 38, I'll recall back our trig ratios, so katoa. So sine is opposite, which is QX over 377.3, and QX is going to be 377.3 sine of angle 38. So QX going to be 232.3. Now find the area occupied by the park. So as you could see that PQRS is not a shape that we already have identified, but just a quadrilateral. So what we can do is we straight away take two separate triangles. So when we take two separate triangles, this and the other one is this one. Now, so total area of the park is area of triangle PQS plus area of triangle QRS, which is going to be 1 over 2 times, now any two sides that you multiply and it is given 460 times 377.3 times sine of angle 38 plus 1 over 2 times 377.3 times 325 sine of 32. You may refer to previous lectures related to the sine rule and area of any ordinary triangle. I already have discussed that in detail. So this is it. When you apply them in your calculator, you get the desired answer. This lecture is more focused on cosine rule, so I'll prefer solving them mainly. Let's look at another question here. So in this, you're to find out angle ADB. So this is the angle that you need to find out. So let's take a long route, but we'll try to understand. So if I take this triangle ADB, so from triangle A, D and B, I need to find this angle D. and I have this angle and opposite side. So let's try applying sine rule there. So sine of angle 50 over 2 centimeters is equals to sine of angle D over AB. There are too many unknowns in an equation to follow, and that is why this is practically not possible to apply right now. So we can think differently, and we try to look at this triangle and this angle. So rather than finding out right away ADB, I'm finding out angle ADC, and I can see that since whole BC is a straight line, I can straight away subtract from 180 degrees to find this angle later on. But as I said before, that triangle ADC, looking at triangle ADC, now you are to find out the angle D and all the three sides are given. And this is what the condition we discussed initially, when all the three sides are given and you are to find out any angle. This is the case for cosine rule. So I'll straight away write 4.5 squared. The angle that I need to find, I'll write the opposite side to it on the other side of the equals to 3.5 squared plus 2 squared minus 2 times 3.5 times 2 cos of angle D. 4.5 squared is equals to 3.5 squared plus 2 squared minus 3.5 times 2 is 7, 7 times 2 is 14 cos D. I'll just confirm. Now, a lot of students, what they are used to of doing is 16.25 minus 14 cos of D equals to 20.25. Now, I've noticed that a lot of students, what they do is they subtract these two values straight away. Please note that there is a cos D which is multiplying. So according to Bodmas, you cannot subtract unless you multiply the value of cos D, and you don't know cos D. It is an unknown in this. So it's better to take this on the other side is equals to minus 14 cos D. Now 4 is equals to negative 14 cos D, and negative 4 over 14 is equals to cos of D, and D is going to be cosine inverse negative 4 over 14. 106.6. So angle D is 106.6. This angle here is 106.6. Now what you need to find out is this angle, and as you could see that it is a straight line, so you write since CDB is a straight line, angle ADB is going to be 180 minus 106.6. So angle ADB is now 73.4. The shortest distance of A to Now from A to CB, this is the perpendicular distance. Now if you keep this, name this point X, and from triangle ADX, I have angle which I just figured out as 73.4. The opposite side I need to find out, the red one, AX, and hypotenuse I have 2. So sine of angle 73.4 is equals to opposite, which is AX over 2, and 2 sine 73.4 is going to be AX. So AX, or the shortest distance, is 1.9 centimeters. The length of BD. So you have to find out the length of BD. If you could just pause the video, try finding it out yourself, and I'll solve it anyway. So for dB, if I just erase these values, so this here is 73.4. For the side dB, which I need to find, I need to have an opposite angle as well. So I just add. I'll write part 3. Angle A is going to be 180 minus 50 minus 73.4. So 56.6. Angle A is equals to 56.6. I can write this down here as 56.6, and I straight away apply sine rule. Sine of 56.6 over dB is equals to sine of 50 over 2, and you can solve them by just cross multiplying. So this is all about cosine rule. In our next session, we'll talk about bearings and how they are helpful in our daily lives. Until then, take care. Bye.